Now that you have some basic tools in your hands, we can try and do some small examples with calculations. So let's have a look at this first one. So we have a couple of trigonometric equations, and we would like to check whether they are so-called trigonometric identities, meaning that the left and right hand side of the equations are equal. So what we have to do, we have to type those in. And for instance, we can type the left and right hand side separately and then just see if the coming result is the same. So let's start with the usual clear. And now our formulas. So we have in the first one, let's do the first one first. So we have sine power 5 of some angle theta. So we have angles theta and phi. So I will actually define them. I'll give them some values. Maybe pi over 3 and pi over 4. So now we have our first equation. So I will call those left hand side 1 and there will be a right hand side 1. So sine power 5 theta. So remember that you cannot put that power here on the sine, because first you have to tell Matlab that you are actually wanting to calculate the theta, sine of theta, and only that number, so this result, gets raised to power 5. So in textbooks we would write like this, or sine square theta. That's the common notation. But in Matlab you have to give it information that's actually sine theta that is raised to power 5. If you wrote sine power 5 theta, you would get error first on the sine power 5 because it would just say unknown. Or maybe it would say not enough input arguments, because sine is a function in Matlab, so, and it needs to be given that angle on which we calculate the sine. So that would be the case. Okay, so we have left hand side and now right hand side. It's a bigger fraction, so I like to do it so that when I know that up there is a lot of things, I immediately open and close brackets so that I make sure I don't miss anything in numerator. And then the denominator is just 16, so it's quick to write it like this already. And now let's see what is in there. So it's 10 times sine theta minus 5 times sine 3 times theta and plus sine 5 times theta. Okay. Now as you keep typing and there are lots of parentheses, you can kind of trace them if they are paired. So always, like here I'm on the right hand side, or the closing parenthesis, and when I move around it with the cursor, it kind of underlines this respective pair. Then same when I'm on the last one here, I can see that the very first one in my line is also underlined. If you have some extra parentheses, for instance, I have one here, then you see this small red mark here at the end of the line, so it even says possibly a parenthesis is missing. Same, and even here when I move around these ones, it kind of shows still that they're paired, also this one, but now when I move around this one, it kind of shows it crossed, so that it should be probably removed. Similarly, when you have an extra one at the end, there is a similar reaction, so parse error at parentheses, so it means normally that it's an extra one. And once again, when I move around with cursor around it, it's kind of crossed away. Okay, so now I think formula looks okay. There is one more remark I would make. Remember that on paper, when we write, for instance, 3x, we all know that it actually means 3 times x. But Matlab is not that smart, and you actually have to always tell it that it's 3 times x, or like we have there, sine 5 times theta. So otherwise you would get an error. So let's run this and see what comes with our left-hand side, left and right. And you can see they are the same. This is the format short, as we discussed. You could see it in longer one. Format long. And once again, left-hand side 1. And right-hand side 1. And you can see that up to those 15 decimals, these are still the same. Now, what can happen is that what you might want to do to compare them, you could also make left-hand side 1 minus right-hand side 1. However, you have to remember that these kind of calculations are numerical approximations. They are not exact. So what now can happen is that actually this difference is not 0. It might be something like 10 to power minus 20 or something different. So as you can see, it's actually something very small. So this is with precision down to 17 decimals. But that's why you wouldn't be able to just check using the logical comparison, is left-hand side equal to right-hand side. If I do this check, I will get false, so 0. And the reason is exactly that they are only numeric approximations, and they are not precisely the same. But of course, it is close enough for us that we can see that it's really numerical error rather than mistake in our formula. So now when I press enter here, sorry, yeah, I have misspelled left-hand side. So you see logical 0, just because they are not precisely the same, but for us they are still close enough. So for displaying the result, for instance, also you could then have some small if-else conditional statement checking that if the difference between left and right hand side is less than some predefined precision, maybe 10 power minus 10, then you treat them as equal and otherwise not. Okay, so let's try left hand side 2 and right hand side 2. Now let's look at the formula. So we had cosine theta minus cosine phi on the left, and right hand side was minus 2 times sine, and that sine had some fraction, so it's theta plus phi divided by 2 plus phi divided by 2. And now remember, theta plus phi are actually together divided by 2, so we need this extra bracket in here. And this was still times another sine theta minus phi divided by 2. So I'll just copy this piece in here and change the sign. So once again, we expect to see numerically very close results for these two. Let's have a look. Yes. So it means we've typed the formulas correctly. And now you see I chose some any values for theta and phi, and we can change them if you wish to check whether it actually works, so that these formulas are the same, or that they work for any So you could even generate randomly the values in here. I just changed manually, but in any case, they should actually return always the same values, because they are so-called trigonometric identities.